Ruth, sit in the front, please. No, to the left. Okay, not that one. To the right, please. Stop. Okay. Okay, maybe a little bit to the right. I said right. Yeah. Okay, perfect.
Hi, 𝗪𝐶. How are you doing today?
I'm doing alright. We've been in the cloud all day, and now we're recording the video because it's due tomorrow. Please introduce yourself.
My name is Ruth.
Tell us who your teammates with, what's this project about, more information.
Yeah, I'm teammates with 𝗪𝐶, 𝗪𝗵𝗲𝗿𝗲, 𝗪𝗵𝗁, 𝗪𝗪, and 𝗪𝗵𝗲. Why is this project important to you?
First of all, I'm an international student, and this is a 6 credit course, and this thing, you see here, it's worth 40% of my grade, okay?
Because it's worth 40% of my grade. And I'm responsible for this video, so this 5% is also very critical. Slay.
Isn't it cool that when we were kids, we used to be like, oh my gosh, it's a remote controlled car, and we'd get so excited. Now we're making one, so that's just really amazing.
I got so happy, yeah! How many hours have you spent for this lab in total?
Well, almost 2 all-nighters.
I think same as 𝗪𝐶 said, we pulled, so
Yeah.
1.5. Yeah.
And what's this project about, please?
So, this project is about the magnetic field car, where the transmitter would transmit like an induced voltage as a signal, and then the receiver on the end of the car would amplify with the amplifier, then use a comparator to compare whether the signal is high or low, and then read that and interpret that into a command such that it would move forward, backwards, to the left or to the right.
So what were the main difficulties that we faced as a group?
I think for transmitter part, we struggle a bit more on whether the inductor could send out like more than 200 volts of voltage, and also sending like the off time, which is like making sure the waveform is continuously looping in the ISR and doesn't stay always off or always on. And for the car part, we spent a lot of time figuring out the amplify gain, the value of the resistance to the gain, so that it amplifies the voltage received from the inductor. We used like 1,000 at first, and we got like 99 centimeters of range, but then that blew up a few of our amplifiers. So now we scale it down to around 500-ish, and we have like a range around 57 centimeters.
I'm gonna have to reset this.
Our robots also have 2 modes. One is command mode, one is tracking mode. And in tracking mode, basically the car will keep a constant distance between the transmitter and the car, and it would keep track whatever position the transmitter is moving. It will turn when the transmitter start turning. It will move forward, backward, and in all directions. Our car is basically powered by AA batteries, which provide 2 different 9-volt sources. Mainly because one is for the H bridge on the receiver and the other is to power the servo motors.
Can you explain what is the off time function?
So off time is basically a function I created that measures the off time of the transmitted signal. It uses a timer, and it basically turns the timer on and off until it reaches the rising edge of the clock. Once it reaches that, starts the timer. Like it resets the timer and then.
So what can you do for a special feature?
For the transmitter, we were originally given like buttons only, but we implemented the nunchuck. So the nunchuck is the controller, and we also implemented some LED lights, and it would indicate the commands that we send it to the car.
Our group implemented the thermal sensor right next to the inductor as a safety feature. When the inductor is overheated, it will flash a special LED light and then stop the inductor from sending more signals. We coded 2 extra commands to the nunchuck. It is U-turn left and U-turn right.
Last question. What do you think about the person that works near the lab? Thank you for your honest opinion, and we're gonna put it in the video.
No, we're not.
We are.